Experiment number 1. Determine the solubility of chemical substances at room temperature. Aim of this experiment is to determine the solubility of chemical substances at room temperature. Requirements: chemicals like distilled water, water soluble substances like potassium chloride, sodium nitrate, potassium nitrate. Apparatus like thermostat, analytical balance, porcelain dish or watch glass, calibrated weight box, hot plate, pipette and thermometer. Theory behind this experiment is solubility is a chemical property of substance in particular solvent. It is defined as the concentration of dissolved solute in the saturated solution at certain temperature. In another word, it can be defined as spontaneous interaction of two or more components to form molecular dispersion. The component which form the major constituent of a solution is called the solvent, and the other constituent dissolved in it, which may be a gas, liquid or solid, is called as solute. When solute is dissolved in liquid, irrespective of their concentration of a liquid, is called as the solvent. Example: syrup contains 66.7% of sucrose by weight, but water is called as solvent. On the other hand, when alcohol is added in water, the terms solute and solvent are interchangeable. Quantitatively, solubility may be defined as concentration of solute in given solvent at the specific temperature. According to United States Pharmacopoeia, solubility expressions are: very soluble substance is less than 1 part of solvent required for 1 part of solute. Its solubility range is greater than 1000 mg per ml. Freely soluble substance is from 1 to 10 parts of solvent required for 1 part of solute, and its solubility range is 100 to 1000 mg per ml. Soluble substance is from 10 to 30 parts of solvent required for 1 part of solute, and its solubility range is 33 to 100 mg per ml. Sparingly soluble substance is from 30 to 100 parts of solvent required for 1 part of solute, and its solubility range is 10 to 33 mg per ml. Slightly soluble substance is from 100 to 1000 parts of solvent required for 1 part of solute, and its solubility range is 1 to 10 mg per ml. Very slightly soluble substance is from 1000 to 10,000 parts of solvent required for 1 part of solute, and its solubility range is 0.1 to 1 mg per ml. Practically insoluble substance is greater than 10,000 parts of solvent required for 1 part of solute, and its solubility range is less than 0.1 mg per ml. Factors affecting on solubility are temperature, nature of solvent, effect of pressure, particle size, crystal structure, molecular structure, solute-solvent interaction. About temperature, solubility is directly proportional to temperature. Then, regarding nature of solvent, polarity of both solute and solvent molecules affects the solubility. Generally, polar solute molecules will dissolve in polar solvents, and non-polar solute molecules will dissolve in non-polar solvents. Then, about effect of pressure. For gaseous solutes, an increase in pressure increases solubility, and a decrease in pressure decreases the solubility. For solid and liquid solutes, changes in pressure have no effect on solubility. Then about particle size. Particle size affects solubility. As particle size decreases, the surface area increases. As the surface area of particle increases, it causes greater interaction with solvent. However, after some time, increase in particle size decreases solubility due to formation of agglomeration. Then about crystal structure. Amorphous form of drug is more soluble than crystalline form. Then about molecular structure. The change in molecular structure strongly affects the solubility of the compound. Solute-solvent interaction. Strong solute-solvent interaction equate to greater solubility, while weak solute-solvent interaction equate to lesser solubility. Then about determination of solubility. For this, first prepare saturated solution of substance and analyze it by using either evaporation method, volumetric method, gravimetric method, or by instrumental method. Then about applications of solubility. It is useful in pharmaceutical dosage forms. On the basis of solubility, one can calculate dose of drug and its stability in GI tract. Aqueous solubility is an important parameter in biopharmaceutics. Solubility is an important parameter in purity of drug. Solubility provides information about composition, structural arrangements, and intermolecular forces. Then, about procedure. Thoroughly clean all required glassware with the acid and then wash 2 to 3 times with fresh distilled water. Take 50 ml of distilled water in suitable beaker. Add sodium chloride in excess quantity into beaker containing water and stir it properly. Raise the temperature to 35 degrees Celsius with continuous stirring. Maintain the temperature for few minutes and then cool to room temperature. Transfer 10 ml of sample into a porcelain dish or 50 ml beaker using a pipette whose tip is covered with filter paper to avoid removal of insoluble substance. Cotton can be used in the place of filter paper. Evaporate this solution using either direct heat or on hot plate or in hot air oven. Dry these contents till constant weight is obtained. Similarly, determine solubilities of potassium chloride, sodium nitrate, and potassium nitrate at room temperature. During this procedure, you have to do some observations like weight of empty beaker or dish, that is W1 in a gram, weight of beaker or dish with solution, that is W2 in a gram, weight of beaker or dish with residue, that is W3 in a gram. Also, you have to calculate weight of residue by W3 minus W1 in a gram and weight of water W2 minus W3 in a gram. By these all observations, you can calculate the solubility of given substance. To calculate the solubility, use this formula W3 minus W1 upon W2 minus W3 multiplied by 100. By all the calculations, you can write the result in such a way that the solubility of sodium chloride, potassium chloride, sodium nitrate and potassium nitrate at room temperature in distilled water was found to be percent weight by volume. Thank you.